Good morning, everyone. This is Mrs. Padmashri from SNS College of Engineering. Today, I am going to discuss the topic Dimensionality Reduction in Machine Learning. Let's move on to the topic. What is this dimensionality reduction? So, this is one of the important topic in machine learning. From the title itself, we can say dimensionality reduction. Something we are going to reduce. What is that? See, if you take any data set, the data set will be having number of features, right? Say for example, if I take the student data set, what all the features or attributes present in the student data set? The students must be having the name of the student or roll number of the student, the address of the student, then maybe some details about the student. This is the main important features present in the data set, right? See, suppose apart from these features, if I have the height of the student and the weight of the student in my data set, consider height of the student and weight of the student is present in the data set. So, is these two features is necessary for this data set? It is not that much important, right? Only if I take a student data set, name, roll number, or maybe the address of the student, these details will be very important. So, some unwanted unwanted we cannot say, like which is not important for this database, that will create what is it? Will create a complexity in the data set. So, what we need to do for machine learning thing, we need to reduce that unwanted feature, reducing that feature. So why we need to reduce? So all the necessary details are there, like age, height and weight is not that much important for student data set. So if we reduce, what we can do, we can reduce the complexity of the data set. So it will the machine will be it will be easy for the machine to train the algorithm. Okay, so like, and in what is, by reducing these thing, what is the advantage that we are getting is we are just improving the performance of the machine. We're just improving the performance of the machine, or sorry, performance of the algorithm, like the final output that we are going to get is the accuracy, right? We are going to find out the accuracy of the algorithm. So how will we improve this accuracy? By just reducing these unwanted features in the data set. In turn, the machine will train the data set very quickly, so that the performance of the algorithm and the accuracy will be more. So this is the concept behind dimensionality reduction. It's the process of reducing number of features in a data set while retaining as much as important information as possible. Okay, this can be done for a variety of reasons: to reduce the complexity of a model, and to improve the performance of learning algorithm, or to make it easier to visualize the data set. The techniques for dimensionality reduction. We have several techniques. Out of that, the most three important techniques are PCA, principal component analysis, singular value decomposition, and linear discriminant analysis. Each technique uses a different method to project the data in lower dimensional space and improves the performance of the algorithm. So, in dimensionality reduction, before we see what are this PCA and LGA, I will be discussing in my next video. And just in this video, try to understand what is the dimensionality reduction. So, it is one of the important thing we need to understand here is the curse of dimensionality. It's a common problem in machine learning. What is this? Where the performance of the model deteriorates, reduces as the number of features increases. This is going to be the curse of dimensionality. Performance of the model is reduced because of when you add more number of features in your data set. So if it is not at all related to the data set, we can just remove it so that your performance will be improved. That is the thing in important in machine learning. So why this curse of dimensionality? Because the complexity of the model increases with the number of features. So it becomes more difficult to find a good solution. So high dimensional data can also lead to overfitting. So the main approaches to the dimensionality reduction, there are two approaches we will discuss here. One is feature selection, other one is feature extraction. First we will discuss about feature selection. It involves selecting a subset of original features that are most relevant of the problem. That like the same thing. If I am giving you the set of student data set, so what are the things which is not needed, I'll remove it and I'll make a subset of those student data set. So the goal is to reduce the dimensionality of the data set and retain as much as important information as possible. There are several methods of feature selection, including filter methods, wrapper methods, and embedded method. So filter method is, it ranks the feature based on the relevance. Like filter, the technique is removing, right, unwanted irrelevant information from the data set. And wrapper methods uses model performance as the criteria for selecting the feature. So if I am selecting this particular feature, this will give you, this will give more performance in my output, more accuracy in my output, so I can select those feature. So that is called a wrapper method for selecting the feature. And embedded method, which combines feature selection with model training process. Feature extraction. What is this feature extraction? Creating new features by combining or transforming the original features. So the goal is to create a set of features that captures the essence of original data in the lower dimensional space. There are several methods for feature extraction, including principal component analysis, very important PCA, LGA linear discriminant analysis, and t-SNE, distributed stochastic neighbor embedding. And PC is a popular technique that projects the original feature onto a lower dimensional space. Okay. So the rest will be discussed. That is the main thing. PCA and LDA I will be discussing in my next video. Keep on watching this video and thank you for watching this video. Thank you.